on this computer. Yeah. So good. Yeah, good day for everyone. Now we are continuing our subject in economic and business mathematics. Now we are going to learn about the application of differentiation or application of turunan. In Indonesia, we call differentiation or derivative as turunan. Let me share maybe I just share my desktop. Okay. Here you go. Okay. Yeah. Okay. Yeah, this is the application of differentiation. Yeah, the first one, the application, is talk about the marginal, or when we are going to find some changes because of the other variable that change. Like the previous tutorial, we learned about the rules of differentiation. If there is an equation and there is some variable change, dy by dx, y function change because of the x variable change, then what happened with the y function? That's called as differentiation. In mathematics of economic and business, this is called as marginal. And the first one that we are going to learn is marginal revenue. Marginal revenue is the derivative of total revenue. So you need, or we need, to find out the total revenue first, and then we can create the marginal after we have that function. So the derivative of total revenue with respect to demand. So dTR with respect or by dQ, the demand, the quantity demanded. Or in the previous tutorial, maybe we call it as a QD. So the marginal revenue of a good is defined by MR, marginal revenue, that can be derived or can be found through differentiate the total revenue with the quantity demanded, or dTR by dQ. TR, we know how to get TR. TR can be derived or created through this equation, P times Q. Or, sorry, flick. Wait a minute. Yeah. TR can be derived P times Q. This is the marginal revenue. Or if the thing that given in the case is average revenue, then we can also find out the average revenue equals to TR by or divide with Q. So the TR, if the average revenue given, then the TR also equals to average revenue times Q. So it depends on what is the case or what is known by the question or the case. So this is the example. If an example, there is a demand function, P equals to 120 minus 3Q. And then we are asked to find an expression for TR, total revenue, in terms of Q, and find the value of marginal revenue, MR, at Q equals to 10. using A, differentiation, and the one unit increase approach. Nah, before we try to solve that problem, I will like to explain the other things about marginal. So marginal revenue, it is also can be get, or basically the marginal revenue equals to the differentiate or the change of TR because of the change of Q. So this equation can be transposed to give delta TR equals to MR times delta Q. Delta TR equals to MR times delta Q. Or change in the total revenue equals to change in the total revenue. Delta is changing. So change in the total revenue equals to marginal revenue times the change in demand. Let's try to solve this problem to make the clear perspective. Yeah, I would like to open the, I found a new application that we can see both of the slide, and maybe just minimize it, move it here, so it will not disturb us. And then here you go. So if the demand, just a bit, yeah, okay, perfect. If the demand function equals to P equals to 120 minus 3Q, and then find an expression for TR in terms of Q. This is actually, we need to find out the expression of TR, or we have to find the TR function first, or TR equation. Sometimes English, reference in English is very clear and very helpful to make us understand what should we do step by step. But in this case, actually, if we are or you are asked to find an expression or find the value of MR, marginal revenue at Q, so actually we know that we need to find out the TR first. So because MR equals to DTR by DQ. That is impossible if we have no idea about total revenue equation to solve this problem. So we need to find out the TR, of course, because to find out the marginal revenue, we need this equation. So the TR, if I write in this, I write in this part, TR equals to P times Q. 120 times Q, 120Q minus 3Q power by 2 or quadrat. So this is the TR. TR. Wait a minute. This is not clear. TR. So if we have the TR, let's make it yes. Yeah, if we have the TR, then we can easily put the TR here. So now we can have marginal revenue equals to TR 100 T 120 Q minus 3Q quadrat by DQ. Okay, so we have MR and C the Q. So the change, or the one that will be differentiated, is the Q here. And we can easily, or we can use the rules of differentiation to differentiate or derivate or menurunkan this function. So 120Q by dq equals to 120. And then minus 3Q quadrat. Then we can put this power, put this power by 2 and multiply it with 3. So it becomes 2 times minus 3, minus 6. And then Q and subtract it with 1. 2 minus 1 equals to 1. We don't need to put or to write 1. And we have the marginal revenue. This is the marginal revenue. 120 minus 6Q. And then the question asks or required us to find the value of MR at Q equals to 10. So we need to insert Q equals to 10 in this equation. So MR equals to 120 minus 6 times 10. MR equals to 120 minus 60. This equals to 60. The MR is 60. So this is the MR if we are calculating it using the rules of differentiation. And then if the one unit increase approach, so we can use the second way. So how about delta TR if the marginal revenue and the differentiation or the change of demand already known. This is in this case. So the 1 unit increase approach, 1 unit increase. That means the change of quantity is plus 1 unit increase. So if we will solve it using this equation, so we can write again in this part, delta TR equals to MR, this is an MR, 60 times delta Q times 1. So delta TR or the change in TR equals to 60. This means if Q or quantity increases by 1 unit or delta Q or the change in the Q is 1 and the formula delta TR equals to MR times delta Q, 60 times 6 times 1 equals to 60. So a 1 unit increase in Q, 1 unit increase in Q.
Sir, I have a question.
Yeah.
We got 60 on MR. And then the question is if Q increases by 1 unit, doesn't it means that the Q become 11?
Yeah, I will explain it after this. So, yeah, this is the idea first. So 1 unit increase in Q therefore leads to an increase in TR of Q about 60. So this is the idea. And then we also want to try the one that you just asked. So it means if we have this equation, we have this TR. I will expand this. If we have this TR, so it means we have 60. The TR is so this is equals, or we can also try to calculate it. Wait a minute. Maybe I just give a green. Yeah. So if the Q equals to 10, then we will have TR. If we put it in TR, so how about the TR? How is the change in the TR or total revenue if the quantity increased by 1? So if in this case we have Q 10 equals to 10, then we will try to find out if the quantity equals to 10, and then what happened if the quantity now become 11. So what is the TR? What is the change, or what is the number of the TR, or the change in TR because of the change in quantity? Now, let's try to solve it. So TR equals to 120 times Q. Q is 10 minus 3 times 10 quadrat or 10 square. And then we will have TR equals to 100. 1,200 minus 300. The TR then will be 900. So this is the TR if the quantity equals to 10. Then what will happen if the quantity increase by 1? If the quantity increase by 1, so the quantity will be 11. And then how about the total revenue? 120 times 11 minus 3 times 11 powered by 2, or 11 square. And then the TR equals to 120 times 11. The calculator. 120 times 11. 1,320. 1,320 minus 11 quadrat times 3. 363. 363. So the TR will be 120, 1320 minus 363 equals to 957. So based on this case, if, just write it with blue, if the quantity increase is +1, if the delta Q equals to 1, then the TR from 900 become 57. So it becomes this. So the total revenue will change about 57. So the marginal actually not exactly show the same calculation number, but this is give a brief explanation or estimation about the marginal, about the change. So if it will be compared, this one will say 60. But if we use this exact calculation, we will have 57. So there is some tolerance between this number. So the marginal revenue actually just want to estimate how much if the change of the total revenue if there is a change in total quantity demanded without calculate or put the number into the equation. So an example, if we already know the marginal revenue, and then somebody or boss or the company asks how much the change or the marginal of revenue if there is like 100 or 1,000 change in quantity. So we just need to multiply 60. An example, if there is a change 1,000, then we don't have to put 1,000 and calculate it with 1,000 and then how about the TR? But we can simply calculate or multiply it with this marginal revenue. So if the delta Q about to change 1,000, then the total revenue will change about 60 times 1,000, 60,000 dollar. That is the example or the explanation of marginal. Okay, that's for the first marginal. Let's try to continue. Yeah. So if I also give some note here, a 1 unit increase in Q therefore leads to an increase in TR about 60. About 60, approximately 60. So it might be not exactly 60, but it's around 60. That's the marginal things work or interpret. The second one is marginal cost. Marginal cost is the derivative of total cost with respect to output. So the marginal cost can be calculated using this formula. MC, not MC, marginal cost equals to D, TC by DQ. Using a simple geometric argument, it is easy to see that if Q changes by a small amount of delta Q, then the corresponding change in total cost is given. So this is actually the same things with this one. Delta total cost and MC. So if we write it like this, MC equals to delta TC divided by delta Q, then you will have this formula. This is just put delta TC here and multiply it with MC. So actually MC times delta Q equals to delta TC. So this is just the same thing with the different component in left and right hand side. Delta TC equals to MC times delta Q. Change in total cost equals to marginal cost times change in output. So this is the next example. If the average cost function of good is average cost, so we know that marginal cost is derived from total cost. So we need to find out the total cost first. And there are some ways to calculate or find the total cost. Put it here. Let's see. So if we have this, maybe I need to clear this. How to clear it? All. Actually, the simple one is use. Oh yeah, we can. This where it's become blank with the bomb sign. Okay. If so, now I will write in whiteboard. Is there any question? Patria has okay. So if the AC, we know the AC. Now we are going to learn in Blackboard. The previous is whiteboard, now Blackboard. Using chalk. I think your generation have no idea about using a whiteboard. Maybe you already in elementary school or kindergarten, you learn in whiteboard already, not in Blackboard maybe. 2q plus 6 plus 13 divided by q. So this is the function that is known or given. So average cost. Find an expression of MC. Marginal cost is derived from total cost divide or not divide, yeah. The DTC by DQ. Because this is not a division, or we don't have to like divide this equation with q to q divide by q and then become 2. No, because this is the derivative, not. So we need the rules of derivative, not the division or calculation in number. So that we need to find out the TC first. Total cost, because of the function that given is average cost. So total cost actually equals to average cost times Q. So the total cost equals to 2Q times Q, 2Q quadrat plus 6Q plus 13. This is the TC, total cost. And then the marginal cost, if we already know the total cost, we need to just differentiate it. 2Q quadrat. So 2 times 2, 4Q. 2 minus 1 become 1. 4Q plus 6Q, 6 power by 1. 1 minus 1, Q power by 0 equals to 1. So 6 times 1, we just can write it as 6 only. And then 13. All the constant, if we differentiate it, it will become a 0. So we don't need to write this result or the 0 result. Then this is the expression of MC. And then if the current output is 15, the current output is 15, then estimate the effect on total cost of a 3-unit decrease. So we are going to find out first the marginal cost if the quantity is 15. So then the marginal cost equals to 4 times 15 plus 6. The marginal cost 4 times 15 is 60 plus 6, 66. Then estimate the effect on TC of a 3-unit decrease. 3-unit decrease. So if we use this, estimate the differentiate of or the effect of delta TC if the delta Q equals to 3 unit decrease. Let's make it wider. So if the estimation of TC equals to MC times delta Q. Delta TC equals to MC 66 times 3 unit decrease, mean minus 3. So the difference here, or the change of total cost is 66 times minus 3. 66 times minus 3 become minus 198. So if we want to, so this is the estimation. If we are going to find out the exact number, so we can just write in this part. So the quantity equals to 15. Then we need to calculate the total cost. If the quantity equals to 15, then the total cost, maybe I just write it here. Quantity is 15. Then the total cost equals to total cost. Total cost equals to 2 times 15 power by 2 or quadrant plus 6 times 15 plus 13. Wait a minute, let me make it a bit wide. Plus 13. Yeah, this one. So the total cost equals to 2 times 15 quadrat, 225 times 2, 450, 450 plus,
90.
sorry, 90, 15,
90.
90 and 13. So 90 plus 13 plus 450, 553. 13, 500,
53.
553. Okay. So if now the quantity decrease, let put what color is can be read yellow. So if the quantity decrease 3 unit minus 3, it will be 15 minus 3, 12. So the total cost will be 2 times 13 quadrat plus 6 times 13 plus 13. The total cost equals to 13 quadrat times 2, 338, and 6 times 13, 338 and 78. 338 plus 78 plus 13. The total cost equals to, this one is 8. 338. Nah. 338 plus 78 plus 13. 429 and then minus 553. 429, 429. And this will be the, let's become
Excuse me, sir.
this one. Yeah.
I think it should be
Oh,
12,
salah
not
nih.
13.
Yeah. 6 to 8 Oh, wait a minute. Which one is wrong? This one. 13 quadrat times 2. 338. Oh, sorry. Not
It should
13,
be
but
12.
12.
Yeah, 12. Yes, sir.
Okay. Okay. You need to erase a lot of what's that? How to, sorry. Let's give it and give it enter and erase this. This one must be not 13, but 12. 13 dari mana nih? Sesat ini. Oke, hapusnya. It's different. Must be this one. Okay. So after this, I think we have used the other color, but not black, because the eraser will still have a white. Or if I change this. Okay. So the background is in the back side. Okay. And put it become 2 again. Now 2 times 12 quadrat 6 times 12 and plus 13 still, because the 13 is in the formula. So this is the one that correct. 13. Okay. Let's calculate it. 6 times 12 from the back. 72 12 times 2. 288 288 and then 72 and 13 plus 72 plus 13. 373. 373 minus 553. 180. Actually, this is 553 minus 373. Yeah, just want to make you not confused. 180, the change. So the change of the quantity, the total cost and total cost is about, so if I let this, it will be 553 and it become 373. So the reduce or the decrease is 180. From 553 becomes 373. 180. Let's see. If we use or we calculate it using the differentiate, then we will have the number about minus 80, minus 180. But if we calculate it using the marginal, which one? Using marginal. This is the marginal. If we just calculate it using marginal, we have the marginal, and then because the difference is minus 3, then we will have minus 198. So this is the approximation. If the 3 unit different, then the approximate or the marginal will be 198 or 180, yeah, around that. Usually in the brief calculation, maybe the company or management will say it's about 200 different. So you want to decrease, like an example, 30 unit, then just multiply 200 or 198, or yeah, just 200 with 10. So it will be 2000, about 2000 different if the quantity change to become reducing about 30 unit. So decrease about 30. Minus 30 means about minus 2000 will be become a total cost of this cost. So an example, if the production is 15 and then the production become 12, or if the production is 150, then it become 120. So there is about minus 30 unit decrease. Then the total cost will be also decrease about $2,000 or whatever the currency is. So that's the marginal cost, the idea of marginal. So actually we need, or we can easily calculate the change of the function upper, or the original function, if there is a change in the other variable, in this case in quantity or output demanded, or in output, because this is a cost. For cost is just Q as an output, but for revenue, Q as quantity demanded. Yeah. Okay, that's the second application of differentiation, marginal cost. The third one is production. The idea is just the same with the previous one, but for production, this is quite simple. So in production, the output is called as Q, and then there are two kind of the common variable in production. The first one is L, or labor, and the second one is K, or capital. So capital and labor. So we can calculate the marginal product of labor or the marginal product of capital actually. So there are two things that may be change and influence or give an effect in the output or the Q. In this case, in the first case, the variable that influence the quantity or the output is L, labor. So the marginal propensity of labor is the derivative of output with respect to labor. Actually, the simplest way is, see, this is the function, and then differentiate the variable that have L variable. Otherwise, if there is no L, it will be a constant or constanta. And all things, all constanta, if we differentiate it, it becomes 0. This is the example. If the production function is Q equals to 100, let's boom this again. Write it. Yeah. Black and white is very cool, eye-catching, or easily to see. Okay, just put it a bit in the left and just a bit. If we have the Q equals to 300 L, square root of L, so we can write it L power by half, and then minus 4L. where Q denotes output and L denotes the size of the workforce or labor, calculate the value of MPL. So the MPL, marginal propensity of labor, equals to dQ by dL. Labor is very important part or component in quantity or in production. That's why, yeah. That's why in the recent time, there is a new regulation for labor, because the labor is one part of component. And there are so many demonstrations right now regarding this regulation. But actually, if you are not or you are disagree with some regulation or any things in this word, maybe you can like try to learn carefully and then say your opinion or your idea with a good way as an academic person. Actually, it can be changed. I think all the rules that created by human must be, can be tolerant or can be changed if there is a new phenomenon or new trend about or new things happen in the world. So back to this case. So marginal propensity of labor equals to dQ by dL. In this case, we are not talking about regulation, but we are talking about the output or production output, production number that change because of the labor change. Q. So because this is a minus, we can use the rule of derivative 300L power by a half. So half times 300, 150. L half minus 1. Minus 1. So it becomes minus half. And then minus 4L minus 4. So this is the MPL. And then if we are or you are asked to find out the MPL when the L equals to 1, then just put L as 1 in that function. 150 times 1 minus half minus 4. Or minus half, actually, we can put it back or we can move it. This one. L minus half. This is also, we can also write it as MPL equals to 150 divided by square root of L minus 4. 150, if we put it here, 150 divided by square root of 1. Square root of 1 is 1. So 150 minus 4 equals to 150 minus 4, 146. So this must be 146 too. But let's try it to use a calculator to solve this problem. So 1 x minus, how to create minus? 0.5 half minus, and then it becomes 1. 150 times 1, 150 minus 4, 150, oops, where is that? 150 minus 4, 146. If the A or the B equals to, the BL equals to, equals to 9, then the MPL equals to 150. You can use this or we can also using that this one, this function or this formula, minus 4. 100 divided by 3, yeah, minus 4. 100 divided by 3 is 50 minus 4. It becomes 46. If you want to calculate it using the other formula, it also doesn't really matter, I think, if we write it 100 times 9 minus half minus 4. Let's try to prove it. 9 power by 9 power by what's that? Half minus half. This is equals to blah blah blah, and then times 150. Then it becomes 50. 50 minus 4, and it will be 50 minus 4. This is just the same, and it will be 46. Yeah. C and L, you can just use the same way to calculate what is the MPL if the L is 100, and what is the MPL if the L is 2,500, using the same equation. Or you can use either this formula or
Green.
yeah, or this. Sorry, it's
Apa sih? Dicoret.
or this formula. This is just the same thing. Okay, next. Consumption and saving is the fourth application. We have two common marginal propensity that is maybe quite familiar when we discuss about consumption and saving in linear or non-linear function. And now we will see the derivative of consumption with respect to income. So the MPC equals to, this is the formula for MPC. MPC equals to dc by dy. And then MPS equals to ts by dy. Where is an income? Don't forget. S is saving, C is consumption. Y equals to C plus S. They remember about this formula. If you have an income, if you have money, then we can do two things. The first one is consume it or spend that money, and the second one is save it. So income equals to C plus S. Consequently, we can differentiate both sides of the equation. So divide all of this using just use a formula to differentiation. So dy by dy, this c equals to dc by this dy plus s equals to ds by dy. So dy by dy equals to 1, dc by dy equals to mpc, then ds by dy equals to mps. Or we have one more common, or this is also a common or rule of thumb of the formula, not really rule of thumb, but this is the formula that we can also derive from this statement, which is 1 equals to mpc plus mps. This is the easiest way to calculate MPS or MPC if one of them already known. are already calculated, but the problem is the formula or the equation is not a linear. If linear, we can only, an example, C is A plus by B by D. So the saving just simply minus A plus 1 minus B by D. But yeah, this is just for a linear. But how about if we are going to find out the S if, or the other way? An example, in this case, if the saving function given, and then the question is want us to calculate the values of MPS and MPC. If we have S, so we can easily have MPS with the differentiating ds by dy. That's it. But how about the MPC? Is it quite complicated if we want to change this S function become C using an example this solution? It is impossible, yeah, nearly impossible because this is a quadrant. So it's complex. So the most or the easiest way to solve it is using this formula. Let's try to solve this problem. I think we don't need a lot of time to solve this problem. Okay, write it again. If the formula or function given s equals to 0.02 y powered by 2 minus y plus 100. Then calculate the MPS. The MPS is very simple. Just find out the differentiation of S by dq, not q. Be careful. If I write it q, so this all of them are going to become a constant. So the result will be 0 because there is no q in this function, only y. So this is actually not dq, but this is by dy. dy. So y is the variable that we are going to focus in differentiation. 2 multiplied with 0.02, 0.04 y minus 1, 100 equals to 0. We don't have to write it. 0.04 y minus 1. That is the ds. Then if it is asked, calculate the value of MPS and MPC when y equals to 40. When y equals to 40, then the MPS, just put the value of y here, minus 1. This is the value of y. So the MPS equals to 0.04 times 40 equals to 1.6. 1.6 minus 1. So we have MPS equal to 0.6. After we have MPS, this is very easy to calculate or find the MPC. MPC 1 equals to MPC plus MPS. If we need to find out MPC, so we can easily move MPC there or just keep MPC here and move the the MPS there. So actually it is like this, 1 minus MPS equals to MPC. Or we can write MPC equals to 1 minus MPS. So MPC equals to 1 minus 0.6. 6. This is the MPS. So the MPC is 0.4. So calculate the value of MPS and MPC. MPS is 0.6, while the MPC, marginal propensity to consume, is 0.4. The brief interpretation. So this indicates that when national income increased by 1 unit from its current level of 40, so this is the concern or starting point, then savings rises by approximately blah 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 unit. Savings rises approximately 0.6 unit, whereas consumption rise by only about 0.4. Actually, unit. At this level of income, the nation has a greater propensity to save than it has to consume. Actually, marginal propensity to consume or save, this is represent how is the thing that usually the people or the percentage that is based on the income. So in this case, the percentage of saving is greater than the percentage to consume. But usually in the individually things, the consume will be higher than the saving. Maybe for most people. Yeah, that's about the marginal propensity or about the marginal things. One of the implementation about differentiation. Still in this case, this is the last things in application of differentiation that we are going to discuss. Wait a minute. The topic, or we call it as elasticity. Okay. So elasticity, actually the proportional of percentage changes. This is still talk about the changes, because mostly if we are talking about differentiation, we are talking about the change of one variable that will be affected or will affect to the other variable. In this case, in the elasticity, the first one is price elasticity of demand. So price and price elasticity of demand. Elasticity given with this variable A HD, elasticity of demand, D represent the demand, equals to percentage change in demand by percentage change in price. So this is the percentage change in demand, and this is the percentage in price. Or we can call it Q1 minus 1 is the difference in Q, and this is the difference in P. Then dQ by or divide by Q times P. This is you move the back to the upper and the upper and the down, and it will be like this one, and we can grouping delta with delta and variable with variable. dq divide by delta p with p and q. So if we have a limit, so the idea of the change in q by the change in price will be dq or dp. dq by dp, or this will be a differentiation. So the elasticity then have this final formula. This is the final formula that we are going to use to calculate the elasticity. Elasticity of demand equals to dq by dp times p divided by q. Or if the p is given, p function q, then sometimes we don't need to change the p become q function p first, but we can just differentiate it, but change it or move it in the back, or it become 1 divided by dp by dq. Actually, dq and dp, we can write it 1 dp p divided by q. Just the same. Actually, this formula, both of these formulas are the same, and times p divided by q. So actually, this is the same formula, but in this first formula is q by dp. In this case, p by dq. It depends on the case or the question. We will see it after this. Yeah. So elasticity if in the demand, because the demand curve slope downward, then the value of E is always negative in this case. So it is conventional to avoid this by deliberately changing the sign and taking negative. So actually, to calculate elasticity, we need to absolute or make the absolute in the result. So whatever the result will be a positive. Then we can compare it using this category or this rule. If the elasticity result less than 1, it is called as inelastic. If equals to 1 is elastic, unit elastic. And if greater than 1, this is elastic. What is actually the elastic and not elastic, unit elastic? So if this is the simple explanation. So if there is delta P, this is the change of P, of price, and this is the change of Q, delta Q, from Q1 to become Q2, an example. So let's see. It is, so it can be in this point, this is the coordinate, an example, this is the Q1, and this is the price 1. And this is the price 2 and Q2. So in this case, the thing that called as elastic actually, if the change in price not as big as the change in quantity. So it also can be said if there is a product that will be changing a lot if the price just change a bit, either decrease or increase. The example is one of the example, as I know, in this case, if the price just move a bit, but the quantity will be changed a lot, is like a gold jewelry. If the price like decrease a bit, then there are so many person want to buy that product. Smartphone, very expensive smartphone, Samsung or iPhone that just has launched or published at this year, and then there is a pre-order and there is a 10% cashback, or maybe 1 million rupiah cashback from 20 million rupiah. That's a quite a small number actually. But if you pay attention, sometimes even the price changing is very little or small, then the quantity is changed very huge. This is the thing that in mathematics or in the application of mathematics in economic and business is called as elastic. On the other hand, if the price change a lot, but the quantity doesn't really change, or the quantity will be changed only a little, this is called as inelastic. So the price elasticity, the price is inelastic with the quantity demanded. The example is like salt, maybe, salt. Every food or meal sometimes needs salty to make it tastier. But if the price of salt, an example, decrease, or there are a lot of discount of salt, an example, if your mother cook soup with uh, commonly or usually with only 1 tablespoon of salt, then if the price of salt decrease, I think your mom still use 1 tablespoon of salt. Not, oh, because this is cheap, then I will add maybe 2 or 3 more tablespoon of salt in the soup. That uh, will not be happen. So this that means that product is inelastic. So like salt or uh, yeah, some product is inelastic with the price. Even the price change very different, but the quantity will just like the same quantity. Unit elastic is the constant change between price and quantity. So if the elasticity equals to 1, then this is called as unit elastic. But the things that most important maybe we need to know what is elastic and inelastic. Two different things about elasticity. Elastic means, yeah, even if the price change a bit, then the quantity change a lot. That's elastic. If the price change a lot, but the quantity not really change a lot or only change small, in small number, that is inelastic. This is the example of elasticity. Elasticity, there are two things or two kind of elasticity. The first one is elasticity of demand, and the second one is elasticity in supply. In supply, before we try to solving the case, I just want to give all the description or explanation about elasticity first. So the price elasticity of supply have this formula. The formula actually the same with elasticity of demand. P divided by Q times dQ by dP. Or if we have dP or P as the main function, then we just can differentiate dP by dQ, but make it down, or 1 divided by dP by dQ times P by Q. This is just the same formula actually. The explanation just the same. So the elasticity and inelastic has the same meaning, but in terms of supply in this case. So if the price changes a lot, the quantity supplied just change a bit, because that's why it called as inelasticity. But in elastic, if the price maybe change not to huge, but the quantity change a lot, This is the quantity supply in this case, change a lot. That's called as elastic. Now, back to the case. This is the last case in this tutorial. Okay. So I will erase this part. Yeah. Given the demand function P equals to 100 minus Q. Calculate the price elasticity when the price is 10. When the price is 10, then what is the elasticity? Let's see the formula. This is the formula because we have P. Oh, I just want to show you because this is a simple equation. I want to show you both of the solving equation. So in this case, we can just write or calculate EHD using, because the P is the function and P function Q, so dP by dQ. So the elasticity will use this formula of solving. So dP by dQ times P by Q. And then the other one is I won't use this one. dQ EHD with dQ by dP times P times P by Q divided by Q. So in this case, I just try to make it Q function P. So Q equals to 100 minus P, right? Move the Q over there and the P and change the P to the other part. Bing. The Q minus Q over there and the P over there. So minus become plus, plus become minus. This is just the same, right? Yeah. Okay, let's try to solve it now. If I have it, then EHD, if I let it, this one, dP by dQ, then P function P, the thing that we are going to differentiate is the Q, then 100 divided by 100 differentiate by Q, constant 0, minus Q, differentiate by Q is minus 1. Okay, got it? And for this thing, green ya, dQ by C, the differentiate. This is the simplest way is the Q or the up is the function and the thing that we will differentiate is the variable in the back side or in the downside. In this case is P. So 100 divide, not divide, but differentiate by dP equals to 0 constanta and minus 1. Just the same actually. And let's, so if I have this 1 divided by dP, this is minus 1 times P, this is the P equals to 10, then the quantity, the Q is 100 minus P, yeah. 100 minus 10 actually. 100 minus 10, Q, this is a Q. Q equals to 100 minus P because we know that the P equals to, let me have, what color?
Blue.
Blue. Okay, blue. This one. So the Q, if, I just write it here, if the P equals to 10, then the Q equals to 100 minus 10.
10.
Q equals to 90.
90.
Yeah, 90. Then this is 90. 90. So this is just the same if I write it dq by dp. Q by dp. This one minus 1. 10 minus 90. Oh, this is just the same. EHD equals to minus 10 divided by 90. 90 equals to 0 0.11. 0 0.11. Just the same thing with this one. So, yeah, because this is the same, so I don't want to write it twice. But in this case, like I said before, you can use the formula because this is a demand. So you can calculate it with minus or make the EHD absolute. It become 11, 0 0.11.
Blue.
Because this is 0 0.11, then let's compare it with this thing. Demand is said to be blah blah blah. Compare it with 1. Compare it with 1 with what color? Red. Red?
Orange.
Orange. Okay. Compare it with 1. Oh, sorry. 1. 1.
1.
So 0 0.11 is less than 1.
1.
What happened if it less than 1? Less than 1. So that means inelastic. Is inelastic. Look, the first rule. EHD less than 1. So that means inelastic. So the demand is said to be inelastic at this price. Yeah. Okay. I think that is the application of differentiation in this tutorial. Hope you have a great days. Enjoy your working or study from home. Stay safe and God bless all of you. Bye bye everyone. I will stop this recording.